Hello, Wizards in Training.
Welcome to Josh and Kristen's Chemistry Extravaganza. Today we'll be doing some ideal gas law problems. So the first one asks, what is the mass in grams of 12 liters of oxygen, O2 gas, collected by water displacement at 23 degrees Celsius and a room pressure of 745 torr? The molar mass of oxygen is 32 grams per mole, which we'll need to know later.
So what are we going to do first, Kristen?
All right, so when we see that it's collected by water displacement, we have to account for the pressure of water vapor. So we'll eventually be using Dalton's law to find the pressure of the gas. So let's start with our ideal gas law, which is PV equals nRT. And since we're finding mass in grams, we have to solve for moles right here. And then since it's water displacement, as I said before, we'll have to use Dalton's law to find the pressure of the gas. We're going to look on our water vapor pressure chart and find that the pressure of the water vapor at 23 degrees Celsius is 21.1 torr.
So do we subtract that from the room temperature?
The room pressure, yes, we do.
Pressure.
Yeah. So in ATM, since we have to, when we use the ideal gas law, it has to be in atmospheres for the pressure units. So we get 0.9525 atmospheres. The volume is 12 liters. That's our gas constant, ideal gas constant. And temperature has to be in Kelvin, so 23 plus 273 is 296 Kelvin. So now we're just going to plug and chug and to find moles. We end up getting 0.4706 moles of O2, but it's asking for grams, so how are we going to do that, Josh? What do you think?
Do we use the molar mass now?
And we're going to make our train tracks here. So after you calculate that, you get 15.1 grams of oxygen.
Shouldn't it be 4 sig figs?
Nope, it's 3 sig figs because our least amount of sig figs is 3 with the 12.0 liters.
I see.
All right, so our next one is not collected over water, so the pressure given is the pressure of the gas. So we're going to start with our ideal gas law, and it's asking us to calculate the molar mass, so we're just going to have to do an extra calculation at the end. Our pressure in atmospheres is 740 divided by 760, which is 0.9737 atmospheres. Our volume is 1.07 liters, which it gives us in the problem. This is our gas constant, 0.02 or 0.08206. And temperature, you just add 273 to convert to Kelvin, which we get 285 Kelvin. What do you think we're going to do next, Josh?
Well, now do we plug it into PervNERT, the rearranged one?
Yes. So we're going to put 0.9737 atmospheres times 1.07 liters, and then we're going to divide that by the ideal gas law constant times the 285 Kelvin, and we end up with 0.044548 moles.
So is that our final answer?
Nope, because it's asking for the molar mass. So how are we going to calculate the molar mass in this situation?
Divide moles by the number of grams.
Well, grams per mole.
Grams, sorry.
You were close. 44.5 grams per mole is our final answer. And are those sig figs looking okay for you, Josh?
Yeah, because the liters and the temperature both only have 3 sig figs.
Good. All right. How do you think we're going to start this next problem, Josh?
So we need volume, so we'll rearrange PervNERT to get V on the left side alone.
But how do we do it if they didn't give us any of the other numbers besides 1 mole?
Oh, but they tell us it's at standard temperature and pressure, and standard temperature is 0 Celsius, and pressure is 760 torr.
So can I just plug in 0 Celsius in the ideal gas law?
No, it has to be Kelvin, and torr has to be converted to atmospheres.
Yep, we have to remember that when we're using the ideal gas law, units do matter, so we have to use atmospheres and Kelvin when we're calculating, as well as liters. So we're finding 1 mole. Then the ideal gas law constant is always the same. Temperature is 273 Kelvin, so when you add 273 to 0 degrees Celsius, you get 273 Kelvin. And pressure is 1 atmosphere, which is also 760 torr. So we're going to plug it in to solve for volume. Plug and chug, and you should get 22.4 liters.
That looks familiar.
Yes, because 1 mole of gas at standard temperature and pressure is always 22.4 liters. All right, so the next one is again collected over water. So what does that mean, Josh?
We have to use Dalton's law.
Which is?
Pressure of the room equals pressure of the gas plus the pressure of the water.
Yep. So it's asking us to find the room pressure. So are we going to do that at the end or the beginning of this problem?
At the end. And so, because we need to find the pressure of the gas first and then add that to the pressure of the water to get the pressure of the room.
Perfect. We're going to solve for pressure. So when you have the ideal gas law, that's P equals nRT over V. So our N was given to us, so that's 0.0185 moles. R is always the same, 0.08206. Temperature, we're going to add 50 to 273 to get it in Kelvin, because again, the units do matter in the ideal gas law, so that'll be 323 Kelvin. And our volume, we divide by 1,000 to get our liters, and that's 0.517 liters. What are we going to do next, Josh?
Just plug and chug and then use Dalton's law to get final pressure.
You should end with 0.948 atmospheres. So how are we going to find the room pressure from here?
Well, first convert it to torr, and then look at our chart to find what the pressure of water is at 50 centigrade.
So that should be 92.5 torr. So we're going to add that to our 720 torr. So the pressure of the room is 813 torr. And do those sig figs look right to you, Josh?
Yes.